We are live on Maker Camp. Thank you for joining us on Maker Camp Live today. Here at Maker Camp, we bring you awesome makers, awesome projects, weekdays at 10 a.m. Pacific and 1 p.m. Eastern. Maker Camp and this programming, the daily programming, is supported and brought to you by members of Make Community. So please check us out at make.co. And for today's session, we have Jim Seymour of E-Blox, and that's at myeblox.com. We've got links in the video description, so you can check out more information there. We have Jim Seymour here today, and he's going to be going over some basic circuitry concepts using the Circuit Blox 120 kit. And we also have links to that kit in the description. And so with that, I am going to hand it over to Jim Seymour and take it away.
All right, thanks, Sienna. Welcome, everybody. We're really happy you joined us today because we're going to have a ton of fun showing you how you can greatly enhance your building experience, and in particular, your brick building experience with Circuit Blox and our Circuit Blox 120 set. You may have heard of E-Blox or maybe not. As Sienna said, my name is Jim Seymour. I'm one of the co-founders of E-Blox. Also here today, we have my brother, Joe Seymour. He's in the background here working the cameras and the visuals. Okay, but as you can tell, he's also co-founder, and so we are a family business that launched a little over 3 years ago. And our mission has been to take one of the greatest toys ever, Lego. I'm pretty sure all you kids out there either have tons of Lego or have played with a lot of Lego and have great sets. But our mission is to take that and greatly enhance your building experience to make it more fun as well as more educational. And the way we do that is by taking the parts that are directly compatible with all of your Lego, but in our parts, we embed electronics into them so that as you're building, you're not just building structures, you're actually building circuits and learning how to design 3D circuits into your structures so that they come to life with lights, sounds, and motion. I mean, how cool is that? All right, we're going to show you that today. We have 3 different product lines. And Joe, you just maybe show real quickly here. We have Circuit Blox, we have a Power Blox line, and we have a Story Blox line, okay? Today, we're going to focus on Circuit Blox, and in particular, this 120 project Circuit Blox set. The number there means the number of projects, 120 projects, okay? And we're going to show you some of the coolest builds of those 120 projects today. Now, you may have seen this link and prepared for this, and if you got your own 120 set, then you can actually build with us as we go. But if not, don't worry. You're still going to have a ton of fun watching us build. And at the end, we're going to show you how you can get your own 120 project Circuit Blox set, okay, where you can access that. And also, I wanted you to know that this session is being recorded. So you can watch us build today, but then you can get your own set and go back and you can build with us just like you were doing it live, okay? So with that, we're about to get started with the fun. Now, before I ever really get into building with E-Blox, there's one thing that I do. I transform from Jim Seymour, co-founder of E-Blox. Oops. I'm trying to get my lab coat on here. I transform from Jim Seymour into Dr. E-Blox, okay? It makes me feel really smart when I wear this lab coat and this hamburger hat and these glasses, but the truth is actually, it's kind of chilly in here, so I put the coat on and having a bad hair day, so I thought the hamburger hat works. And honestly, with these glasses on, it's completely blurry, so I'm gonna put them here for now, but we'll use them when needed, okay? All right, now, before we start building our first project, just want to show you about the Circuit Blox parts, okay? You can see all of them are here from our 120 project set. The first part here is just a wire part, but it looks kind of like a Duplo-like Lego part, all right? But with our sets, you can see there are little pin connectors in there. Those pin connectors are what enable you to make electrical connections when you plug the parts together. Okay, so it's not just mechanical, it's also an electrical connection. And then these parts act like wires, but then some of the parts have electrical components in them. Like this one has a motor in it, okay? This one actually has a speaker in it so that we can make sounds. Some of the parts have LEDs or lamps in them, all right? Some have switches, so we can turn things on and off. And then there are some advanced parts. There's a sound module that comes in the set. There's an amplifier, so we can adjust the volume of things with this volume adjust, okay? And there's actually an FM receiver module. That's right. One of the projects we're going to do today is to build our own FM radio. And in the set, you get a base grid to build off of and the battery module. That's, you put 3 AA batteries in there so that when they're in series like that, there's a ground connection here that's 0 volts, and then you get about 5 volts out here. Everything is fully safe. You're not going to get hurt. There's low enough power here, and if you do create a short, there is actually a circuitry in here to protect the batteries from being shorted, and it beeps at you, and so everything is fully safe proof. And of course, you get your manual with 120 projects that come in the set. All right, so let's get to building something cool. We're going to start, if you have your 120 set with us, with project number 8. And Joe, why don't you throw that up on the screen here real quick to show people what project number 8 is going to look like as we start to build it. Okay, there we go. There's project number 8. As you can see, there's the battery module in there, there's a switch and the motor. And one thing I want to point out, if you look very closely on the motor, there's some markings on there, little line markings in that number 95. And so you need to make sure that the motor is in the correct direction there, okay? Because there's, if you look at the bottom of it, there's only pins on 2 of the dimples, okay? All right, so we can come back live here. I'm building project number 8. Okay, I got my switch in, I got the motor in, and then I'm completing the circuit. One thing about circuits, okay, the battery, this provides the voltage that's really kind of think of it as providing the power to push current through your circuit. Kind of think of current as almost like water flow, but it's actually electrons that are flowing. But the only way that the current's going to flow is if there's a closed circuit from the battery module through your components back to the battery. So from the 5 volts back to the ground. So that's what we did here. We created that loop. We're going to put this fan on the motor here. And the switch is the thing that's preventing the closed circuit from right now, keeping it open. But when we push it, look at that, the motor spins. Oh yeah, that spins pretty fast. It's a nice fan actually. Okay, so pushing the button down, close the circuit, makes the motor spin. But why didn't it launch? Okay, it spins, but it's not launching. All right, well, we might have to put our glasses on for this because we got to think. If you look at your fan here, this fan has 3 blades on it, and the blades are actually angled, okay? And so let's take a close look at this as Joe puts up a little diagram on the screen here, okay? If we look at the fan, and by the way, when we push the button, it would spin in the clockwise direction, okay? And if you look at the angle of those blades that's shown there, you can see that when it spins in the clockwise direction, the airflow is going over the blades. And when the airflow goes over the blades, it's creating a force in the downward direction. And downward is not the way we want the force to go if we want this thing to fly, all right? So if you think about it, if we were able to get this fan to spin in the counterclockwise direction as shown on the bottom right corner, then the airflow would go underneath and it would provide a force up, which is actually called lift. Okay, and that lift is what could make the fan fly. So if we look at the next slide real quick, we're going to build a circuit that has the motor in the opposite direction now, so that when current flows through that motor in the opposite direction, that'll make it spin counterclockwise. Okay, So it's still a simple circuit, although we're going to add a few more parts here, okay, so that we have a little more space to make our fan launch. Okay, but we got to build the circuit right like that, put back in the motor, but we're going to turn it around, okay, so it's in the opposite direction. We got to still put in the switch right there. Get a 2-wire that goes in here. There's a 4-wire that goes there, a 2-wire here, and a 3-wire. It's really easy to build these circuits just from the pictures that are in your project manual. All right, so now we got the closed circuit. Let's try this. Ready? Whoa! Look at that. That thing launched way up in the air. Woo. Oh man, I could play with this all day long. This is so cool. Oh. You know, this is how airplanes and helicopters work, okay? If you think of a helicopter, it's actually got blades just like on your fan blades here that are angled like that, and when it spins, air flows underneath them, pushes it up, and that lifts the helicopter up. Same way for an airplane, okay? The wings of an airplane are angled, so when the air goes underneath, it provides that lift that makes the airplane fly. And you know why airplanes and helicopters never use Uber to get around? It's because they always prefer to use Lyft. All right, you know, kids, if you don't get that joke, you got to ask your parents to explain it to you. But one thing I got to warn you, I mean, Dr. E-Blox here, he is good with explaining circuits and everything, but he's got really bad jokes, okay? You're just going to have to deal with it for the next few minutes, okay? All right, well, one thing is we're at Maker Camp here, which means we want to get creative with things, okay? So I encourage you, when you build this fan circuit, to come up with some cool games, okay? I've thought of a couple here that I'll let you in on. One thing I like to do is, because you get 3 fans in your set, see who can, you know, angle this and see who can launch the fan the furthest, okay? Each one gets a fan, launch it, and see whoever launches it the furthest wins the game, okay? Or this one is really my favorite. Get an empty box, put that in the middle of the room. Could be the box that your product comes in, okay? And stand 10, 12 feet away and try to launch that fan into the box. It's not as easy as it looks, I'm warning you. It's really hard. It's really fun. And I just am gonna launch this thing a few more times because, you know, these motor circuits, you know why I like them so much? It's because they're fantastic. All right, bad joke of the day number 2. Okay, that's over. Next, we are gonna move on to our next project, okay? Actually, before that, we're gonna do one more thing. We are gonna show you how the motor works, okay? Before we go on to the next one, I wanted to explain this motor because it really intrigues me how the current comes in, and whenever the current comes in, it makes the shaft spin. I mean, how does that happen, okay? So Joe, why don't you put up the next slide on the screen here. Okay, here's a picture of the circuit that we got. Okay, a battery is in the circuit with a switch, and when we turn the switch on, that makes the current flow through the motor, and that makes the shaft spin. Now, in order to understand how that happens, we need to understand a little bit of physics, okay? And that's what's in the bottom right corner here. What physics studies have shown is that when current flows through a wire, and that's the blue line there, okay, flowing through the wire, it actually creates a magnetic field around the wire. And those are the red circles that you see there. There's actually a right-hand rule where if you put your thumb in the direction of the current, the magnetic field will flow in the direction of that your fingers point, okay? So that's one thing. We got to just keep that in mind. When current flows through a wire, it creates a magnetic field around it. Now, if we go to the next slide, if you take the magnet, and actually for a second, why don't we just go live for 1 second here, because I'm going to show you with this magnet, okay, you get a magnet in your 120 set. And when you hold it near the motor, it's actually attracted to it. See how it's attracted to that? And that's because in the motor, there actually are magnets, okay? So if we go back to the picture here now, there's a picture there of the inside of that motor. And you can see where the arrows point with the magnets. There's a magnet on each side of that motor that's creating a magnetic field right across the shaft. The shaft is the thing that spins in the motor. And then you also see in there, there's some wire, a lot of wire just wound around the shaft. And when you wind it like that, that's typically called a coil, okay? So now when we get current to flow through that wire and that coil, it actually creates that big magnetic field that we talked about. And that's a second magnetic field now. And when that magnetic field sees the magnetic field of the magnets and it's opposing it, then that creates a force that moves the coil. And since the coil is connected to the shaft, that's what spins the shaft. And that's how a motor works. Now, it's actually a little more complicated than that. And you could do a search on Google for commutators, but that's the basic idea. So, you know, if we come back here, the idea is that when you have current go through the motor, you're creating from electrical energy into magnetic energy that then creates a force to mechanical energy. And that's what makes the motor spin. Pretty cool, huh?
So we've got a question here from
Yeah.
Jen.
Okay.
Asking if the different colors of blocks have different properties.
So in our sets, the different types of components can come in all colors, okay? Generally, the wires are blue, okay? And then the motor, it can come in different colors. We've had motors that are purple or yellow or green. So it's not necessarily the colors that define what the functionality of the shape of the part is, but there are numbers on every single one of the parts. So like the motor is numbered 95. And whenever you see a 95 on our parts, that is going to be a motor, okay? Similarly for like the wires, they have the number of dimples on them. This is part number 3, so it's a 3-wire. Number 3 will always be a 3-wire. So it's the numbers that really define the functionality of it. And the different colors are just to make it pretty and make it look cool, okay? All right, good question. Okay, next, why don't we put up the next project on the screen there? It's going to be project number 52, okay? 52, and we're going to get into making some sounds, okay? Here's the circuit that we're going to build, and you see in there, there's a part number 11. That's called a 3-in-1. That's the thing that's going to be the sound module that creates the sound. And then there's a speaker in there where we can hear it. And then there's some switches so we can make different sounds. All right, so I'm going to start building this thing. Okay, we got a switch in there. One of the things you see on there is a level block. The level blocks, when you look at your parts, even though they're both blue, some of them have pin connectors in them and some do not. Okay, the level blocks are there just to provide a lower level that doesn't need an electrical connection. And then the ones with numbers on them are the ones that have the pins in them and make the electrical connection. All right, so we're going to build here to connect this switch to the battery. Okay, and then looks like there's a 4-wire up here that the switch is going to be connected to. There's actually a big 5-wire at the bottom that would connect the 2 to. Okay, and we've got to provide power. You can see there's a little 3-wire on the bottom there that connects to the ground of the module 11. And then there's another 3-wire that connects to that 4-wire that provides the 4.5 volts. And then we got to put in the speaker. Okay, and that speaker there. And one more switch. Okay, and so now I think we can come back live. I think we have our project built here, okay, with everything just like the picture. All right, make sure all your parts are down nice, and we turn it on. That's pretty cool, huh? Some space battle sounds. Okay, and that's what sounds will make when that 4-wire is on the 3-in-1, okay, in that position. But let's try moving it over, okay, to the next position. Let's see. Anybody's birthday out there? We built this one just for you, okay? All right, one more thing. Let's take that 4-wire out and press this. Oh, sounds like an ambulance. And if I press this button, the police are after me. Yikes. All right, better turn that off. Okay, that was cool though. Now, again, we're here at Maker Camp. We need to get creative. So what I encourage you to do, these are really cool circuits, but see how you can build something that relates to the sound you're making. So as I mentioned at the beginning, all of our parts are directly compatible with Lego. Here's a Lego grid, okay? And here are the parts from Circuit Blox. As you can see, they connect right onto the Lego grid. So you can build like that fan circuit we launched, you could build that right on top of a Lego tower, okay? The other thing is, if you have Lego parts like these, okay? This is just a normal 2x4, it's a 2x2. These parts fit onto the grid, okay? So you can actually build your Lego parts right onto the grid. So what I want you to try to do is, let's see, we made those space battle sounds. Try building that circuit right into your Millennium Falcon, if you have a Lego Millennium Falcon kit. Or you can build your own ambulance or police car and then build the circuit that makes the sirens. Or how about this? This would be a great one. Right before it's your mom's birthday, build a birthday cake around the thing that makes the birthday sound and hit that button and play happy birthday for her on her birthday. I swear, if you do that, I bet she'll buy you even more E-Blox. Okay, she'll love it. All right, well, while you're thinking about cool things that you can build while making these sounds, I just want to take a closer look at this 3-in-1 module, okay? That was the thing making all the sounds, and to be quite honest, I have no idea why they call it a 3-in-1. But, you know, it makes a lot more than that sound, but I don't know, it's a cool name, I guess. But how, you know, it's making all these sounds in just a module this small. How do we do that, okay? Why don't we pull up the next slide, okay? Because it turns out that there's been advances over the years in something called semiconductor technology, where we can make what are called integrated circuits, or ICs. Now, this is a very advanced field, but all you really need to know is that if you have a big circuit, like I pulled one, I just found this on the internet. I have no idea what the circuit does, but it's a huge circuit of transistors and capacitors and resistors and other electrical components. And if I was to actually build this circuit with actual parts, you know, it'd be the size of this whole grid in front of me here, okay? But because of the advances in semiconductors, we can actually get all of that functionality and implement it down into a very small integrated circuit or IC, or sometimes it's just called a chip, like shown on the bottom there, okay? So the main point is we have been able to have great advances in being able to miniaturize all these circuits using semiconductor technology and being able to build integrated circuits or ICs. That's how your cell phone, you ever imagine, you know, cell phones, all they can do now, not only between talking and texting, but all the apps that can do that. I mean, we never could do that without all of the advances in being able to do integrated circuits in those things. All right, so why don't we come back live for a second, because if you take a look at this number 11 block, you can see on the back there, there are some of those components, some little ICs. Some of them are actually some fuses and resistors and stuff, and actually there's a big glob of black there that's covering up the main IC that's doing all of the sounds. We cover that up because we know you kids out there are really smart, and if you know what part that is, you'll probably go out and buy it and just build your own circuit and not buy E-Blox, okay? So we're not gonna let you see what that part is, but trust me, there's an integrated circuit right in there that's making all of the sounds. That's really cool. You know, I spent many years studying semiconductors in college, and it took me a long time to understand them. But when I finally understood them, I told my professor, I see. All right, we made it through another bad joke. Okay, let's move on to our last project. project number 119. Let's put that up on the screen now. And this one is my favorite. This one is where we are going to build our own FM radio, okay? As you see here, we're going to be using some of those more advanced modules. There's a number 24 module in there. That's our FM receiver. There's a number 14 module in there. That is our amplifier. And there's a number 38 module. It's a volume control. Okay, and then the speakers in there and some switches because we're going to need to change channels and an on-off switch. Okay, so let's start building that thing and see how it works. All right, I got a 3-wire that goes in here, and I can put my switch in the lower right. There's a 5-wire coming right across that's providing power from the battery to the module 14. There's a 6-wire on the bottom there going across because that's going to provide our ground. 4-wire provides the ground up into the 14 module. And then there's another 3-wire right at the end. And the switches go in there and connect to that 3-wire. Okay, and we put in another 4-wire to provide power to that, or ground to that 24. And then we need a 1-wire so we can connect to that switch. And then, oh yes, the spring wire. Okay, that goes in a terminal there on the number 24 module that's called RF. That's going to be our antenna. Okay, and then the last thing is we need the speaker to go in. Okay, slide the speaker. All right, I think we're ready to come back here live. We've got the whole circuit built. Let's try turning it on. Okay, push the button. Oh yeah, that's an FM radio station. And I can change the channel. Let's see what else we can find. It's scanning. When you hit the channel, it's scanning for a news station. Okay. That's cool. I think I like that other song better. I'm gonna go back to the other one. And by the way, if you hold the antenna, your body becomes the antenna. And it actually gives you better reception. You can be your own DJ too and just adjust the volume here. Totally cool, huh? It was awesome. You know, again, we want to get creative, okay, in how we use this. Now, I know all you kids out there, you got your iTunes list, you're using Pandora, Spotify, and all that. But you know what? Sometimes just listening to the radio is just the best because you never know what's going to come up next. There's also, I had an application of this recently. You know, we've all been kind of stuck at home a lot lately because the movie theaters are all closed. Haven't been able to go to the movies, okay? But if you're lucky like me, there's actually an outdoor theater near us. It used to be called drive-ins in the old days, where they have the big screen out there. But they don't just blast the sound to everybody. They actually transmit it over the air as an FM channel, okay? So you need a radio to actually hear the movie that's on the screen. Now you could do that with your car, okay, but then you got to leave your car on the whole time. So what we did, we built our E-Blox FM radio and brought it to the drive-in theater, and that's how we listened to the movie. It was so cool. I mean, I saw and listened to Jungle Book. I love the bear in Jungle Book. He's so funny. And Raiders of the Lost Ark, Indiana Jones. Those were the movies we saw when we brought our FM radio to the drive-in theater. So get creative and, you know, use the stuff that you build in Maker Camp. It's really cool. All right, one more thing. Now, this circuit's really cool, and I just want to explain a little bit more about all the stuff we've been talking about with FM radio. Okay.
So
yeah, is there a question
before
there?
we move on, we do have a question here from Jen again.
Okay.
She loves the FM radio.
Cool.
And she is wondering though if you can get ham radio, which is amateur radio, or is that different?
Yeah, that's the FM is just in the frequency band between 88 to 108 megahertz. That's all you can get. Okay, so the ham radio would be at a different frequency and AM radio at a different frequency. So it's just the FM band that comes in the Circuit Blox 120 set. Okay, but I think some of the best channels are on FM. That's what I always listen to. except for sports talk. That's on AM. We'll have to come up with that next. All right, good question again. Thanks. Keep them coming. All right, so let's put up the slide on the screen here about how FM radio works. Okay. Now, if any of you kids live near a city, okay, where you have a bunch of big buildings, or maybe you drive by one and see it, at the top of those buildings, a lot of time you'll see some really big antennas, okay? Some of those antennas are actually FM transmitters, and FM stands for frequency modulation. And what frequency modulation means is that the information that's trying to be transmitted from that tower to your radio is actually stored in the frequency of the signal, okay? That information could be the music signal, the talk radio, okay, the news channel, whatever's trying to be transmitted, it's stored in the frequency of the signal. And then those transmitters are at really high power, like kilowatts of power. So they get transmitted and broadcast everywhere. They're all over the buildings around here, they're around your house, they're everywhere, as long as you're close enough to one of those towers. And then the circuit we built used the spring wire as an antenna to capture that signal out of the air. That's a radio wave signal. And then the 24 module, our FM receiver, it looked at the frequency of that radio wave and was able to pull out the information in it, the music signal, the news channel, whatever. And that's what comes out on your 24 module, labeled output. And we fed that into an amplifier because the signal level out of there was pretty low. We fed that into an amplifier module through our volume control so that we could adjust the volume. And then the amplifier fed into the speaker. And that's exactly how we received the FM radio, decoded it, amplified it, and played it out of the speaker. Okay? Really cool. These stations are awesome, even though many of them are in Spanish and I don't know what they're saying, but the music's really great. Okay, so now this is usually where I tell one of the bad jokes, okay? But whenever I tell my radio jokes, they really get bad reception. So I decided not to do a radio joke today, okay? At least I thought I did, so. All right, cool. Well, those are the things we built, but I got a couple more surprises for you, okay? Just to show you how much fun I've been having. Remember, I showed you how you could actually add your Legos on the grid, okay? Well, I built a thing that made it look like a radio. I built the radio in here, and actually, I used a couple of 120 sets because I got 2 speakers in here. But I actually built something that looks like a radio, and I can listen to the channels here, just like I did when I built my circuit, and it looks like a radio. That's how you can get creative using your Lego with the Circuit Blox sets. Okay, this antenna actually has better reception, so I'm getting a lot of the noise channels.
So we do have another question here from Ron.
Okay.
He is asking, which of our products do you recommend for K through 6 STEM program? Okay. The most versatile, cost benefit, etc.
Okay, so we have a range of sets in the Circuit Blox line that go anywhere from 4 projects up to 800 projects. Now, in the kindergarten through, I'd say, maybe 2nd grade, maybe even up to 3rd grade, the 4 to 120 projects are the most appropriate. Those really are kind of the starter levels. They really start to introduce you into the basics of how circuits work. And we also have a subline called Circuit Blox Lights, where you don't even have to worry about circuits. You kind of free build. There's just a few modules you put on the battery, and then you free build with it. And so those are appropriate for kind of the kindergarten to maybe 1st grade. And then you get into the 4 to 120 for the, depending on, how far you get, you can get between 1st and maybe 3rd grade. And then we have a few, the 395 and the 800, and those start to get into the more advanced components, like they add the resistors, the capacitors, the transistors. Those are more appropriate for the 3 to 6-year-old, okay? And then when we get into power blocks and story blocks, you kind of apply your learning from Circuit Blox to building your own creative designs and circuits with power blocks and story blocks. And so those, I'd say, are in the 8+ age range, again, maybe 3rd to 3rd grade and up to infinity, because as you can see, I love building with this stuff, Okay, so there is no upper limit on any of these things. Okay.
And we're sharing our website with you too, so that you'll be able to look at our website.
Okay.
To review those different products.
Excellent.
And there are student sets also, if you're looking.
That's right. Thanks for reminding me, Joe. We've just recently come out with student sets where, in addition to getting the project manual, we have written some online curriculum that's animated. Okay. It's written in PowerPoint, but you don't have to have PowerPoint to view it. We offer it in Google Sheets format too, so you can view it on tablets, whether it's iOS or Android or Chromebooks, a computer, even if you don't have Word with PowerPoint. So, you know, those sets, they come with the same sets, the 4 through, there's like 5 of them. There's like the Circuit Blox lights, there's the 4, the 59, and the 120. Those come with student sets where you can get even more and more fun with the animation that's in there. You might even hear a few of my bad jokes in there too. Okay. Great. And at the end, we'll also put up the link here for everything. And again, a reminder, all this is being recorded. So you can come back, view this, get the website. It's all going to be there right at the end, and get your own set and build all this fun stuff with us again. Okay. Any other questions, or?
That's where we're at right now.
Okay. One more cool thing I want to show you. I still have 2 more surprises. This is one where I built this actually with power blocks, but you could use your own Legos to build a tower like this, but it wouldn't light up like this. This is a kind of preview of what you can do with power blocks. But I showed you how I can actually build the Circuit Blox circuit right on top of the tower, and I did that with the fan. Woo! That'll launch right off of the tower. Okay. Woo! All right, so just another example of how you can get creative. Build your big towers with your Lego, or maybe check out power blocks, and then put your Circuit Blox circuits right on top of there. Woo! So much fun. All right, well, as you can see, I've been having fun here, but you know, a few weeks ago, I had a lot of fun. I built a master build cityscape out of just Circuit Blox. Okay, it's too big to be in this room here, but we made a video of it, and we're going to turn it over to Joe to show you the cool cityscape that you could make if you buy a whole bunch of Circuit Blox. And I think we're back. There we go. Okay. Hopefully everybody enjoyed seeing that cityscape. I'm telling you, I had a lot of fun building that. That was awesome. But, well, that is all for today, folks. We have had a ton of fun. I hope you've enjoyed it. And now, just because, as we said at the beginning, you know, if you're looking to get your own Circuit Blox 120 set, there are multiple ways that you can do it, okay? You can visit the Maker Shed site, okay, www.makershed.com. That's www.makershed.com. And they have a nice price on that 120 set that we just built with. Or you can visit our website, www.myeblox.com, www.myeblox.com. Okay, and you can get all of our sets, Circuit Blox, Power Blox, Story Blox. Our Circuit Blox lines, as I said, have between 400 and 800 projects. And some of those more advanced ones, you can build your own wake-up alarm. You can build an induction spinner. You can build some oscillator circuits. I mean, the coolness, it just keeps going through the ceiling. It's really awesome. Okay. All right. Well, again, I hope everybody enjoyed this. And this is Dr. E-Blox telling everyone, stay safe, but still continue having fun and continue learning with Maker Camp and E-Blox. Bye-bye, everyone.
All right. That was great.
Okay.
Okay.
All right. Stop recording.